prolonged in the later stages. The problem with placentas is that we don't know the factors in the placenta which have changed in the later part of placenta and pregnancy. And those of us that have actually done deliveries and have delivered placentas will remember that very often they're calcified. In other words, they've aged prematurely, and this is a major factor in the restriction of oxygen delivery. In that situation, premature birth and post-mature birth are both risk factors. So what are the sequelae of compressing the head of an infant? Lack of oxygen and what is termed reperfusion injury. Now, I'll just say a few words about reperfusion injury, because essentially this is what was discovered when heart transplants were considered and the animal work was done to show the feasibility of transplanting hearts. Data which is from the 1950s, which as far as publications are concerned, are about as inaccessible today as the 1850s. It doesn't exist on computer yet, and I suspect it never will. But when hearts were coupled up to the circulation, having been taken out of an animal for several hours, it was recognized that the heart became damaged. They took samples of the venous blood coming out of the heart and found that as the blood came through the heart, it damaged it. And it wasn't long before it was recognized that the damage occurred as a result of supplying the heart with oxygen. And here's the paradox, that free radical injury and reperfusion injury occur because you deprive the organ of oxygen. So in other words, hypoxia, lack of oxygen, sets the seal on reperfusion injury. So in other words, if we have a situation where an organ or a baby is going to be deprived of oxygen, it is setting the scene for when the oxygen is resupplied for free radicals to be formed. And that is simply because when we resupply, we don't resupply enough. Now, we don't have time to go into the background scientific work which has shown that if you give a large dose of oxygen, when you reperfuse the excised heart, you avoid free radical injury. There are lots of paradoxes in this business, and it's really very difficult to convey some of these concepts in a very limited period of time. This isn't because they're difficult, and I don't want to appear in any way patronizing. It's simply that in order to get to this point, there are several steps that you have to take. And if you don't take those steps, you can't simply jump past that information and get to the end result and understand it. You don't expect to do calculus in mathematics without understanding numbers and simple arithmetic. It's not possible. There are the stages that you have to go through. And so when people talk about free radicals and free radical injury, antioxidants and so on, all of this has to be predicated on a certain amount of basic knowledge. And as I said, if you've got the time, it's not that difficult to go through. But medical information is evolving all the time. And so there are pieces in the jigsaw which are being added to information all the time. We don't have the complete picture, of course not. But what we do have now is sufficient information to say with certainty that, for example, if a heart is transplanted, it should be under the umbrella of a large dose of oxygen. And that's because the changes that determine the death of the heart, if it's too long a period, occur because of the changes in the blood vessels, not in the muscle cells of the heart. So we'll amplify this as I go through the talk. So, as a result of the head compression and the lack of oxygen that's created by being born, we have compromise of the blood-brain barrier. Simple concept, blood is very toxic. We have several pints circulating, and it needs to be kept within the tube work. So it seems very strange that blood should be very toxic. After all, it's so vital to existence. But if it escapes outside the blood vessels, and particularly if blood cells escape and break down in the tissues, free iron is liberated. And that free iron is an immense catalyst for the production of free radicals and tissue damage. So hemorrhage is very damaging. The next time you have a bruise, look at it and remember that the release of that material from blood, the red cells into the tissue, is a very damaging process. Now, fortunately, it's usually into muscle or into skin, and it doesn't really matter that much. But that same event in your brain would be cause for massive damage, the extent of which depends on where it occurs in the brain. So, the least problem with blood-brain barrier opening is actually water transfer, swelling. Then, if the barrier opening is severe, you get plasma proteins, the proteins present in blood which escape into the tissue. That sets up the inflammatory response, and we've already heard the inflammatory response mentioned in relation to brain injury. So the inflammation can be a devastating event. Inflammation is a system which has evolved in order to deal with infection. Here it can be inappropriately activated and can lead to damage to you. So these mechanisms, which have a very, very select function, if they're activated incorrectly, can damage you. So white blood cells can also be activated, and they can stick onto the inside of the tube work and interfere with flow. They can also release free radicals. And those free radicals are part and parcel of the normal function of a white blood cell, because they are essential for your resistance to infection. We could not exist if it wasn't for free radicals, oxygen-derived free radicals. They are the basis for microbial killing. We live in a constant fight with the bacteria and the viruses that we meet on a day-to-day basis. And those are dealt with all the time, and it's happening in all of us right now, by leukocytes, white blood cells, which use molecular oxygen, the oxygen you're breathing, add an electron to it to form superoxide anion. And that ability of oxygen to add an electron is essential to our existence. So when people talk about free radical damage, remember we couldn't exist without them. But if this, again, is activated inappropriately, then it leads to tissue damage. Finally, the blood flow through the brain can reduce due to the swelling and to closure of the microcirculation. The capillaries can be shut down by the tissue swelling. Again, the easy way to remember is the clenched fist. You can see the pallor because the capillaries are shut down by the pressure. So, what are the sequelae? If you get global brain damage, then it's clinically evident as a child with microcephaly, because the damage is not only to the white matter but also to the grey matter of the brain. It's a global event. But lesser degrees, you can get periventricular hemorrhage. Now, what are the ventricles? They are liquid-filled cavities, and I'll show you an MRI of the ventricles of the brain shortly. But hemorrhage in that area is into the critical processing areas of the midbrain.